From Fox 35 Mission Control, an out-of-this-world discovery. NASA says it just found a new planet.
The James Webb Space Telescope, JWST, humanity's most advanced window into the cosmos, has once again pushed the boundaries of what we know about the universe. In a recent and groundbreaking announcement, scientists operating the JWST unveiled new findings that offer the clearest and most comprehensive glimpse yet into the true scale of the universe. This monumental revelation, driven by unprecedented imaging power and analytical precision, is more than a step forward. It is a leap across the void, bridging gaps in our understanding that have persisted for generations. Before we start, hit the like and subscribe buttons for more exclusive news. At the heart of this announcement lies the staggering observation of thousands of galaxies in regions of space once thought to be nearly empty. The JWST's deep field observations, far more detailed than those of its predecessor, the Hubble Space Telescope, have revealed that the fabric of the cosmos is far more populated, structured, and ancient than previously understood. Tiny slivers of the sky, when peered into with Webb's powerful infrared sensors, have transformed into sprawling cosmic landscapes, teeming with clusters of galaxies, filaments of dark matter, and blazing cores of ancient star systems. One of the most striking aspects of this revelation is how it reframes our sense of cosmic scale. Where previous instruments hinted at the enormity of the universe, JWST now illuminates it in unparalleled clarity. In viewing patches of space no larger than a grain of sand held at arm's length, the telescope has captured thousands of galaxies, each composed of billions of stars and potentially even more planets. These are not merely distant smudges. They are fully formed, dynamic structures existing billions of light years away, many of them originating during the earliest epochs of the universe. The implication is profound. What we once considered the boundaries of the observable universe are merely the faintest whispers of a reality vastly more complex and immense than we imagined. Webb's advanced infrared capabilities allow it to peer through cosmic dust and gas into the primordial darkness that followed the Big Bang. What it sees there rewrites the timeline of the universe. Galaxies previously believed to have formed several 100 million years after the Big Bang now appear to have taken shape far earlier, perhaps within just 200 million years. This shatters long-standing theories about how quickly matter could have organized itself into stars, galaxies, and black holes. It forces astrophysicists to reevaluate the very architecture of cosmic evolution, from the clumping of matter under gravity to the ignition of the first stars. But it is not just the age or number of galaxies that redefines the scale of the universe. It's the structure and organization of what lies beyond. The JWST has illuminated vast filaments and tendrils of matter stretching between galaxies and clusters, sketching an intricate cosmic web on a scale almost beyond comprehension. These intergalactic threads of dark matter and gas form the scaffolding upon which galaxies are built. Their sheer size defies the imagination, extending across millions of light years and suggesting a universe far more interconnected and dynamically evolving than previously believed. With this deeper clarity comes a realization that the universe's sheer expanse isn't just spatial, it's also temporal. The light captured by JWST's mirrors has traveled for over 13 billion years to reach us. Looking into these images is akin to reading the ancient diary of the cosmos, a record of what was, etched into light itself. Every distant galaxy is a snapshot from a time before Earth even existed, before the sun was born, when space and time were still raw and turbulent. The scale of what JWST shows is not only physical in distance, but temporal in scope. It places us within a continuum that spans eons. Astonishingly, among the numerous galaxies identified, many exhibit structural maturity that challenges previously accepted cosmological models. Some early galaxies appear surprisingly well-formed, with defined spiral arms and dense central bulges, features that should have taken billions of years to develop. This discovery suggests that cosmic evolution may be more rapid and efficient under certain conditions than any model has predicted. It opens a new dimension of inquiry into the laws governing matter, energy, and the expansion of the universe. The telescope's high-resolution spectroscopy has further revealed surprising chemical compositions in these ancient galaxies. Elements such as carbon, oxygen, and even heavier metals have been detected far earlier in the cosmic timeline than expected. These findings imply that the first generations of stars, massive, short-lived beacons, must have lived and died in dramatic cycles, enriching the early universe with the building blocks of planets, life, and future star systems in ways we are only beginning to grasp. Equally humbling is JWST's detection of light that may have originated from the very first stars, population 3 stars, believed to be composed almost entirely of hydrogen and helium. Until now, these stars were purely theoretical. Their detection marks a pivotal moment in astronomy. Direct observational evidence of the earliest stages of stellar nucleosynthesis. If confirmed, this would provide the first empirical window into how matter began to transition from simplicity to the complex forms we see today. This vast expansion in observable data brings with it profound philosophical implications. With every new galaxy observed, with each new sliver of deep time unveiled, our place in the cosmos appears ever smaller, yet simultaneously more significant. We are a species capable of extending its senses beyond the confines of Earth, of building instruments capable of reading the language of light from the edge of time. The scale of the universe is not merely an abstract measurement of distance or age. It is a mirror reflecting the magnitude of human curiosity and the reach of our technological imagination. For decades, scientists speculated on what might lie beyond the observable universe. The James Webb Telescope has not only pushed the observable limit further, it has unveiled regions teeming with activity, density, and age. The universe does not taper off into emptiness. Rather, it continues with complexity and grandeur. Each discovery hints at countless more awaiting beyond our current observational horizon. It provokes a question. If this is what we can see now, what might we uncover in another generation of exploration? These revelations have cascading effects on many scientific domains. Cosmology, particle physics, planetary science, and astrobiology all intersect with this newfound understanding. As the scale of the universe grows, so too do the variables in equations attempting to explain its behavior. Constants may need recalibration. Models must account for greater variability in structure and formation. Assumptions, many of them long held and foundational, are being brought back to the drawing board. In planetary science, this larger, richer universe also means more opportunities for worlds like our own. Each galaxy contains potentially billions of stars, and around them, countless planets. The implication is staggering. If the number of galaxies is far higher than previously assumed, then the number of potentially habitable worlds scales up dramatically. It doesn't confirm the existence of extraterrestrial life, but it makes the argument for its possibility vastly stronger. Astronomers are now looking at regions where galaxies cluster densely, seeking patterns in their distribution that may shed light on the properties of dark matter and dark energy. The way light bends around these massive objects, gravitational lensing, offers clues not only about what is visible, but about the unseen forces shaping the cosmos. JWST's sensitive instruments capture these subtle distortions in exquisite detail, transforming faint background objects into tools for probing the invisible framework of the universe. On the periphery of these discoveries, new mysteries are emerging. Objects with properties that defy classification, too bright, too massive, or too mature for their estimated ages, suggest that something about our understanding of cosmic time or space may be incomplete. There may be unknown processes at work, or perhaps overlooked factors in how we interpret redshift and distance. Webb isn't just confirming theories, it's challenging them, pulling at the threads of established models and demanding deeper explanations. Even our understanding of cosmic inflation, the theory describing the universe's rapid expansion following the Big Bang, is now under renewed scrutiny. JWST's observations might one day reveal anomalies that can't be reconciled with current inflationary models. This possibility pushes theoretical physics to the edge, encouraging the development of new frameworks to better describe the early moments of existence. Looking at the sheer volume of data JWS continues to send back, the scale of the universe grows more vivid and more humbling. Every pixel in a deep field image contains the story of an ancient world, a cosmic epic, or a hidden truth waiting to be interpreted. The grandeur of these discoveries is matched only by the silence with which the universe yields them. In that silence, through cold space and across billions of years, light finds its way to our instruments, whispering the history of everything. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on the true scale of the universe? We want to hear from you. Thank you for watching, and see you next time.